All right, so this is going to be more of a traditional problem for the double angle formulas. The problem says sine of x is equal to negative 2/3, and x is a quadrant 3 angle. So we know that we're dealing with something in quadrant 3. The question wants us to know, the question wants us to find sine of twice that angle, cosine of twice that angle, and tangent of twice the angle. So what they're wanting us to do is basically apply the double angle formula. So like we're trying to find sine of 2x. They want us to do 2 times sine of x times cosine of x. That's how they're wanting us to answer this question. And then come down here and also apply it to the cosine double angle formula. All right, that's how they expect us to find sine of 2x and cosine 2x. So the first thing we need to do in order to apply this top formula, we have sine of x, but we need to find cosine of x. And this isn't, something we've done several times before. One way that you can find cosine of x is by just drawing the right triangle. Technically, this is supposed to be in quadrant 3, but as long as we keep our positive and negative signs, we're going to be fine. All right, so we would label one of these sides as an x. All right. Now we know that sine of this angle is going to be 2/3. So that means 3 is my hypotenuse, and the side across from x, 2. That's my opposite side. I just need to figure out my adjacent. That way I can find cosine. So I'll do Pythagorean theorem here to figure that out. So 2 squared plus b squared is equal to 3 squared. This is a 4. That's a 9. I just need to move the 4 over. So I get b squared is equal to 5. All right, 9 minus 4. And then square root both sides. And we get b is equal to the square root of 5. Nice. All right, now I know what cosine is. All right, cosine is adjacent over hypotenuse. So cosine is going to be root 5 over 3. And then for tangent, you can use this, this triangle. We actually don't even need tangent, but tangent would be opposite over adjacent. All right. So I guess I'll put it down here. Tangent is going to be 2 over root 5. All right. Oh yeah, and then because we are in quadrant 3, I know that cosine has to be negative. Don't want to forget that. That's going to be important. All right, let's go ahead and find sine of 2x. So for sine of 2x, that's going to be 2 times sine of x times cosine of x. And then we're just going to make our little substitutions here. Sine of x is equal to negative 2/3. So it's 2 times negative 2/3. And then cosine of x was negative root 5 over 3. And you just multiply it all out and simplify it. I got 2 negatives, so the final answer is a positive. And we're going to have 2 times 2 times root 5. So 4. Root 5 is our numerator, and then a 9 as the denominator. Okay? So there's our sine of 2x. All right, so notice we started with, it's kind of something important, but we started with an angle that was in quadrant 3, and when we doubled that angle, it takes us out of quadrant 3. Hopefully that makes sense. If you have some angle like maybe 210 here, if you double 210, it's gonna take you outside of this quadrant 3. What would that be? 420. So, and 420 would be 360 plus 60. So that would take us into quadrant 1. This is an example. I don't actually know what the angle is, but if I am in quadrant 1, that means that sine is going to end up being positive. So that's an important thing to note here. All right. If we want to find cosine of 2x, we got lots of formulas to choose from. But the simplest one, I think the simplest one, is going to be cosine squared minus sine squared. So I'm just going to take my answer for cosine x, and square that. Cosine squared minus sine squared. All right, cosine squared, the negative just goes away, and your square root ends up just going away. So you wind up with a 5 in the top, and then your 3 is going to become a 9. All right, and then minus sine squared. So we'll do 2/3 times 2/3. That'll end up being 4/9. And this will end up becoming 1/9. Nice. There's your cosine of 2x. Not too bad. And again, it's positive. And then if we want to find tangent of 2x, we could go ahead and work it out like this, knowing tangent of x. That's one option, and it's not a bad thing to actually try out. It's going to be simpler, though, to think of tangent of 2x as just sine over cosine. So it's going to be sine of 2x over cosine of 2x. All right. So we're going to take this fraction and put it on top of the other fraction. So 4√5 over 9, and then 1 over 9. And then what happens is your 9's end up canceling each other out. You get 4√5 over 1. So that's just going to end up turning into 4√5. All right. And let's go ahead and I'll show you how to check your answer if you're wanting to do that. So that's the gist of it right here. One way that you could kind of investigate further and check your answer is by solving for the angle. All right. So I'm actually going to figure out what x is. Therefore, I'm going to be able to figure out what 2x is. All right. So what I can do here is do my arc sine formula. So inverse sine of negative 2/3. So now the calculator tells me negative 41.81. But the problem with that is that is a quadrant 4 angle. So this is negative 41.81 right here. I'm wanting it to be a quadrant 3 angle. So I'm going to take that 41.81, but I actually need it to be in quadrant 3. So for this angle, it's going to be 180 plus the 41.81. All right. So what I'm going to do is I'm going to tell my calculator 180 plus 41.8103149. Okay, so my actual angle, my original x, is 221. Okay, so like if I do sine of that, that's going to give me negative 2/3. And if I do cosine of that angle, it gives me this nasty decimal, but that's actually what that turns out to be, is that negative √5 over 3. If I divided that, I would get this as a decimal. Anyway, what I'm going to do is I'm going to take that long decimal angle and I'll store it to x. Okay, now I'll check my answer over here. So I found x and I stored that angle to x. Now I'm going to say sine of 2x. Sine of 2x gives me 0.9938. If I find this answer here, 4√5 over 9, I get the exact same thing. And if I find cosine of 2x, I get 1/9. That's what 1/9 is as a decimal. And then, of course, do the same thing with tangent if you want to. Oh, tangent 2x. All right, and that's 4√5. 4√5. Cool. All right, that's it. We'll do another video on it if you're interested.